we've already talked about limits being definite limits, as in what happens as our variable approaches a specific number. But now as we move into indefinite limits, what we're concerned with is what happens if our variable gets infinitely large or infinitely small, that is, approaches infinity or approaches negative infinity. So we're going to take a look at this first one right here, and it says limit of x as x approaches infinity, and we got to remember a limit, we're never actually going to get there. We can never actually get to infinity, but we're asking what does the function get close to? But in this case, it really doesn't get close to anything. It just keeps on getting bigger and bigger indefinitely. So we would say that this approaches infinity. But then we have more interesting questions, like this one right here. Well, what happens as x gets infinitely big if we have 1 over x? So I'm going to use the calculator to help, and we're going to take a look at the graph in blue. Okay, we'll worry about the graph in red in a second. So I'm going to draw these. So the graph in blue is the one that we're looking at right here, and we see that as x gets infinitely big, it seems to be approaching the line y equals 0. In fact, we can use a table to kind of figure this out. If we did 1 over 10, that's 0.1. If we did 1 over 100, that's 0.01. And if I did 1 over 1,000, that's 0.001. And this would just keep on continuing forever. And eventually we get to the point that we would have like 1 over, like, say, 100,000 or a million. And then we're such a small number, we're getting really, really close to 0. So this is something that we're going to want to remember and use to our advantage, that anytime we have a number over x, we're going to get 0 if x is getting increasingly big. But now let's think about this other graph that I had put in here, 2x plus 3 over 4x squared plus 7. Well, before we get to that, let's say, and just kind of extending this example, what if we had, say, x over x squared? Well, then that simplifies down to 1 over x, and that limit would also approach 0. But what if we had, say, x plus 4 over x squared? Well, then what does that approach? Does that still approach 0? Both of these, if we took the limit, this x is approaching infinity, and this x is approaching infinity as well. Well, what is this limit? Does this reduce to a 1? Is it infinity over infinity and we get 1? Is this infinity plus 4? Is this infinity squared? So let's kind of take a look at this example right here. So I have 2x plus 3 over 4x squared. That's kind of similar in case to what I'm talking about right here. And let's take a look at the red graph now. And I see that it goes up, and now it also goes down, and if I keep on moving over, it seems to also be approaching 0, and it's never actually going to cross it. So, what about this case? If I did the limit of x plus 4 over x squared, that doesn't equal 1, that also approaches 0. And let's think about why. X squared, we would argue, is larger than x. So basically, this 4 doesn't matter. It's only this high power of x that really matters. So let's take a look at this one down here. The limit as x approaches negative infinity. And if we take a look at the graph again, I'm going to back up. Oop, messed that up. I didn't want to do that. What does that approach? So we're looking at the blue graph, and x is getting really small. It's going to negative infinity, and it looks like the blue graph, even though it's going from the bottom, it is also approaching 0. So this equals 0. How about this one over here? The limit as x approaches negative infinity of x. Well, x is just getting infinitely small, so negative infinity. So let's kind of think through a couple of particular cases. if I had, say, x plus 7 all over x plus 5, and I wanted to take the limit as x approaches infinity of that. So if I were to put in, say, 1,000, I'd have 1,007 over 1,005. If I put in 10,000, I'd have 10,007 over 10,005. And hopefully you're seeing that as x gets infinitely big, that 7 and 5 ultimately, in the grand scheme of things, they're not going to matter. And I'm going to have x over x. Well, what does that simplify down to? It looks like this is approaching 1. And we could show that fairly easily. So I'm going to shift my view window here. I'm going to put it back to standard. And I'm going to delete these two equations. And let's do the one example I just put up there. So let's have x plus 7 over x plus 5. And let's just test this. Now, we do know from our talk of rationals that at x equals negative 5, we will have an asymptote. And we do. But look, it seems to be approaching, is it approaching 1? Well, let's see here. Y equals 1. Let's graph that and see if it is. It seems to get really close, and if I move over, does it ever cross? They get really close together, but they don't actually ever cross. So, it seems that just the highest exponent of x is what's going to matter. So, here's how we're going to do these, and let's just work through a few examples. These indefinite limits. So, for polynomials, the term with the highest power is what's going to matter the most. So if I want to take this limit as x approaches infinity, I don't really care about these. They're not going to matter because this is the highest power of x, so this is going to have the biggest weight. So what's going to happen? Well, if x gets really, really big, then this term gets infinitely big, and so this approaches infinity. Well, what about this one? Again, these two terms aren't going to matter. The highest exponent of x is going to matter the most. But this time, we're approaching negative infinity. So let's think about this. If I have 2, and I put in negative infinity to the 4th, now I can't actually do this, but I do know that this exponent of 4 will apply to that negative. So a negative to an even power is going to become positive. So it's not going to end up being negative infinity. This is actually going to go to infinity because when I raise the negative to an even power, it becomes positive. This one at the top right, if I put in infinity, these ultimately aren't going to matter. It's going to be this one that matters. So if I put in infinity, odd power, it doesn't matter. This is going to go to positive infinity. Well, how about this one? Now I'm going to negative infinity. It's the same as this one, so these aren't going to matter. It's going to be this that matters. But now let's think about this. If I put a negative infinity into a 5th power, this is an odd power. So it'd be like negative 1 times negative 1 times negative 1 times negative 1 times negative 1. And that all would equal negative 1. But I'm not talking about 1. I'm talking about infinity. So this is going to approach negative infinity. So the odd power, a negative to an odd power gives a negative. So we go to negative infinity on that one. All right, now we have these rationals. Now these are a little bit tricky, but we did do rationals at the beginning of the year, and we said that if we're talking about something going big, that what's going to matter is that highest exponent of x, and we compared the numerator and denominator. But now we're going to look at how it actually works out. So whenever we have a rational, a trick that we can use is to remember that the limit as x approaches infinity of 1 over x, or say any number over x, doesn't matter what that number is, really screwed that up, any number over x, that's going to approach 0. So I want to write this so that it looks like that. And my highest exponent of x, what I'm going to do is I'm going to divide all terms by the highest power of x. And you won't necessarily need to show all this work that I'm about to show, but I will. So my highest power of x is x. So I'll divide everything by x. So I took all these terms and divided them all by x. Now, this one, as x gets really big, that's going to go to the 0. So it doesn't matter. And this one, as x gets really big, that's going to go to 0. And then, of course, x over x, those cancel. So what am I left with? Well, my limit then is 2 over 3. So my limit is 2 over 3. Let's take a look at this one down here. It's going to be the same function, but now I'm approaching negative infinity. And just like we found on the graph, the direction actually didn't end up mattering for this. So if I start it exactly the same way, I'll divide all my terms by x, and I see that this one is going to approach 0, and this one approaches 0 for the reason we talked about down there. These x's cancel. So the direction, this negative infinity, actually ends up not mattering. We still approach 2/3. It's just from, if you picture your graph, 2/3 being up here, it's just coming up from the bottom instead of up from the top. Okay, let's take a look at, and this actually probably should have been over here, but whatever, that was just a sketch. All right, this one. So my highest exponent of x on this one is x cubed. So there it is. So I'm going to divide all my terms by x cubed. That's my numerator. My denominator is right here. Now, let's see what we can figure out. So this term reduces to 1 over x. So this one goes to 0. So this one is 0. This one is also going to go to 0. And this one, we have x squared over x cubed. That reduces to 3 over x. This one goes to 0. And now right here I have x cubed over x cubed, so those cancel, and this one then will go to 2. So basically, my limit is going to be 2 over 0. But I can't divide by 0. And we've said that 2 over 0 is undefined. Well, let's take a look at the reason why it is undefined. So I could do this on a table, but I'll just show it right here. If I did 2 divided by, let's do something close to 0, 0.1. I get 20. If I do 2 divided by 0.01, I get 200. And if I do 2 divided by 0.0000, okay, 1, we would agree that this is very, very small. It's very, very close to 0. And I get 2 times 10 to the 12. That's scientific notation to say very big number. So what is this approaching? Well, if we get this situation with a positive 2 right here, that means that we are actually approaching infinity on that one. All right, let's take a look at the last one. Now, hopefully, having done all these, you get the idea that for a rational, we're going to divide all our terms by the highest power of x, which is x cubed. So this term turns to 0, that term is 0, 0, 0, 0, 0. Those are all zeros. And then at the end, I'm going to have 5 over 2. So there's my answer. All right, we've done a few. How about you give it a try? I am encouraging you to try these 4 questions completely on your own. Pause the video, and in a second, I'm going to go ahead and show the answers. I'm not going to go through all of them, but some of them. And the answers are right here. So the first one, negative infinity. Why is that? Because these terms don't matter. This one's going to matter. If I put in infinity, I have a negative in front, so negative infinity. On this one, now the terms are out of order. So these two terms don't matter. This one matters. So if I put in negative infinity, I have a 4 times, and this would be an odd power. So we're going to have a negative right here. At the top right, we divide all those terms by x squared. And we do see that, now I wonder why I have a negative right there. I actually think that should be positive, but here, we'll think through it. So 7 over x squared, that's going to be 0, and this is going to be 0. And this right here is going to be also going to 0. And at the top we have, that's going to go to 3. So we have 3 over 0. So yeah, this one should be positive infinity, not negative, my mistake. Okay, right here, bottom right, we're going to negative infinity, but that's ultimately not going to matter because this term, and this term, those all go away when I divide by my highest power. And I have 7 over 2. So 7 over 2 right there. Okay, last two examples. So walk through each one of these, make sure we're understanding. I'm going to put in negative infinity. This term and this term don't matter. And this is the term that's going to matter. It's the highest power of x. So I have 3 negative infinity to the 4th. So an even power of a negative. So this is going to infinity because that becomes positive. On this one, I'm going to divide all the terms by the highest power of x. That's x squared. So I have 4 over x squared minus 5 over x squared and 8x squared over x squared plus 3 over x squared. So this term will go to 0 and this term goes to 0. This term, well, that would reduce to 4 over x, so that's going to go to 0. And this, the x's cancel, goes to 8. So I end up with 0 over 8. Well, what's that equal? 0. 0 over 8 is just 0, so that one becomes 0. Okay, I think I lied. I said 2 more examples. But just want to say, well, what if I have something that's none of those? You can always use a table and plug increasingly large numbers in. And when you do that, look for a pattern. See, is it getting very, very negative, or is it getting very, very positive? And that could give you clues. Is it getting closer and closer to a certain number as you put larger and larger numbers in? So just because it's not like something that I've particularly done right now, like we didn't do one with absolute value, does that make any difference? This might be one that we put into our calculator and see, okay, what's going to happen? Does this approach 0 as if the absolute value is not there? And you could test it out and find out.